Today I want to show you what I did with this cool little a-40 from Sansui. This is my favorite amp of all the Sansuis I have. And strangely, being the economy amp that it is, this amp sounds far, far better than my G77X or my 55X. You know, I'm just not even sure I want to go down that road of explaining how that could possibly be, but you're just going to have to take my word for it. This amp just, excuse me, really does it. If it didn't sound the way it did, I would have never, ever put all this time and effort into this amp to do some things to it. So to get to my point, and you may not be aware of this, is that there's a speaker switch on your power switch to connect and disconnect the speakers. Since this unit didn't have a protection board or speaker relay assembly to it, they had to route the speaker wires up to the front here to disconnect the speakers with the power button, to avoid pops and stuff turning the power off and on. So what we wanted to do was omit some of this wiring that comes up to the front here, and we wanted to put a relay board into it, which will probably increase the dampening factor of it as well. So I'll show you what I did here. So here on the front, I stuck another LED underneath my temperature control board. I stuck another green LED on here just to kind of utilize the space that was up here that was utilized on the A80. I like to do things like that. So I just built this little relay board for it, and it's by no means complicated, and it's very foolproof, and it does the job very well. And I have that mounted on the side there. Before I talk about that board, I'll tell you what instigated me doing this. When I put the larger Kenwood transformer into this and increased the filter caps and everything in it, I had some turn-on thump to it, since the timing sequence was different. And you know, it wasn't anything harmful, but after a while it just got on my nerves, and I thought, well, it's time to do something about it. Now back here on the back, I had to remove the binding post for the second set of speakers in order to get the fan and the control board and everything on the inside. So it just really didn't make sense to me why we would need A and B speaker switches if we only have one set of binding posts. So I decided to omit both the A and B speaker switches, because it just didn't even make logical sense to have them on there. And I can probably use those buttons for some kind of added feature that I'll do down the road. And who knows what that may be. So anyway, what they do here is they just take the amp wires coming out of back here and feed them to the front of the amp, because they have to hit the A and B switches, and then they have to drop down, hit the headphone jack, and then they have to tee off, and they have to hit the speaker switch that's on the power switch sub-assembly down here. So there's kind of a big loop of really small cheesy wire, so to speak, and I wanted to get rid of all that. So that's what provoked, the second reason that provoked me to make this little relay board. So there's no doubt that this little relay board will increase the dampening factor probably in a semi-significant fashion, I would say. So now to the beauty of this little guy. The problem I kept running into was I had 8-volt lighting taps here to work with, which was like 9.23 volts RMS, and I had a 12-volt relay coil. This is actually out of a Yamaha A10 amp. So I needed to get at least 12 volts to pull this coil in. Well, the RMS voltage here wasn't really high enough to do that, because best case scenario, with some huge filter caps on a full wave bridge rectifier, the most you could ever get was about 13 volts out of this DC. And then when you look at the loss of the forward voltage drop of the rectifier, the saturation voltage of the transistor, and factor all that stuff in, the most I could really squeeze into this coil was 10.6 volts DC. And I ran it like that for a while on another board that I had built. And eventually, I guess it was like 3 days ago, I just decided I'm tearing it out and I'm going to do it the right way. So it actually took me like 5 days, 5 solid days of futzing with this to get this circuit in here. So my thinking was, how in the world can I get enough voltage to slam these contacts in? And I thought, you know, this is stupid. You know, I've been working with flyback transformers for a long time and voltage doublers. You know, why not just put a voltage doubler in this? So I did that. And that works beautifully. Now I can get enough DC voltage out of the lighting tap to pretty much run anything inside this unit. So this is the cool factor to it, I thought. And I just wanted to show you how I did that. I just pulled my blue wires, which are my lighting wires. They would be blue on the original sansui transformer too, and the original sansui transformer would have a voltage very close to what this Kenwood does, so it wouldn't make a difference which transformer you used. So I just put a voltage doubler here, as simple as that is. And this cap will charge to the peak voltage on this side, and when the sine wave swings negative, then this cap will just charge to the peak value. So in theory, you could get 26 volts setting across these two caps, which was just a really cool thing, because I can do anything with 26 volts inside this unit, but I couldn't do anything with like 9 or 10. So that's what I come up with, and it actually gives me 23 here. These filter caps are really undersized. If I bump them up to what they should be, this voltage would go up to 26 volts, according to calculations anyway. And calculations generally never lie. These would have to be 2500s to bring the ripple down low enough that this point can pull the 100 milliamps that we need off of it. But that's a whole other talk. So we got 20 volts coming into our LM317 now, so we just set that up for 12.6 volts. And that solved the problem there. So next we just wanted to use Sansui's speaker switch to flip this on and off, since they were so nice to put that speaker switch there. So we just found a way to do that. We put a comparator in here, an LM324, or actually it was an LM358. I don't know where I got that at. It was an LM358 I put in there, so I just used half of it. And then I just set pin 3 up here. I had a very convenient voltage. I set it up at 7.5 volts on the reference here. And the reason I did that is to make this time constant of these two resistors through that cap easy to calculate what the time was going to be for this op amp to flip. Because if you remember back, if you look at the time constant of a cap, you know, we look at that at 62% of VCC. So, you know, after one time constant, we know that the voltage on this cap is going to be 62% of what the applied voltage is, which is 12.6. So we just took 12.6 and calculated 62% of it and set that Zener diode here at 7.5 volts. That way this was easy to calculate, and that worked out very well, because otherwise I'd have been changing resistors and this and that and futzing with it until I got the timing exactly where I wanted it, and I didn't even have to mess with it. So and then I just used a 2SA1837 here because that's what I had. This is actually a driver that can be used in the D5 and D7. So I just used that to pull on our relay coil, and then I pulled a yellow and a brown wire up to the front, which connects to the green LED on the front that I showed you. And all we do is just magically connect this circuit ground to this circuit ground when we push the power switch on. So as soon as we connect power to the unit, it just starts this timing sequence and pulls in that relay after 3 seconds. So that's all there was to that. Now the tricky part was making sure this circuit discharges fast enough, because what were to happen if somebody would come over here and start short cycling the power switch? This is the way I think. I overdo things, so you just kind of overlook that. What happens if they short cycle this power switch? Flip it on, then flip it off, and then flip it right back on. You want to make sure this cap has time to fully discharge, because otherwise you could kill your timing sequence and you could end up getting a pop just because you were short cycling the power switch. So we wanted to make sure we dumped all the voltage off this cap when we flip that switch out. And the easiest way I knew to do that was just to clamp this cap through this diode back onto our power supply line, and then put heavy bleeds on our power supply line. So when you disconnect it, all this bleeds back through a 1.2K on here and a 2.7K on here. And that way it's lightning fast to reset, if you want to look at it in those terms. So really that's all there was to it. It just took a while to build it, and it completely solves the problem. So now we have a nice 3-second delay there till when the speakers pull in, and our relay is happy because it's got over 12 volts to it. That's all there was to it. Simple as it was, it did take a good amount of time to implement it. So hope you learned something. I appreciate you watching. Have a nice day.